In this video, we will be solving a few problems based on this formula from probability. The sums that I've taken are from the Maharashtra government textbook, Mathematics Part 1, 11th Standard, Exercise 9.2. Okay, so let's begin with the questions. The first question says, first a 6-faced die which is numbered from 1 to 6 is thrown, and then a 5-faced die which is numbered from 1 to 5 is thrown. What is the probability that the sum of numbers on the upper faces of the dice is divisible either by 2 or 3? So what you need to do is first make the sample space. The sample space will look something like this. On the first die you can have numbers going from 1 to 6, but on the second die only from 1 to 5. So the possibilities are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. You don't have a 1, 6 because like I said the second die has numbers only up to 5. So with the first die you can go up to 2, 1, 3, 1, 4, 1, 5, 1 and 6, 1. And here you can go up to 6, 5. So this entirely is your sample space, and now you need to check what are the favorable number of outcomes for the events that they have mentioned here. So the number needs to be divisible either by 2 or 3. So probability that the number will be divisible by 2 is what? So 1 plus 1 will be 2. The next number 1 plus 2 will be an odd number. The next will be an even number. So alternate numbers, the total is going to be even numbers, and that is why if we have a total of, if you count over here, you have 6 rows, each having 5 possibilities. So the total number of possibilities you have are 30. Every alternate possibility divisible by 2. So if 30 possibilities, half of them divisible by 2. So probability of the number being divisible by 2 will be 15 upon 30. What's the probability that the number is divisible by 3? So you need to check individually all the numbers. You have 1 plus 1, 2, not divisible by 3. 1 plus 2, 3, yeah, that's divisible by 3. 1, 3, not divisible by 3. 1, 4, not divisible by 3. 1, 5, 6, that will be divisible by 3. In the second row, if you check, 2, 1, divisible by 3. Then there will be 2, 2, not divisible by 3. 2, 3, not divisible by 3. 2, 4, divisible by 3. The last one, not divisible by 3. Then there is 3, 1, no. 3, 2, no. 3, 3, yes. 3, 4, no. 3, 5, no. Similarly, here you will have 2 numbers divisible by 3, 2 possibilities divisible by 3, and in the last row if you check 6, 1, 6, 2, 6, 3 is the only possible outcome divisible by 3. So there's 2, 2 and 1 making it 5 and 5 more. So P of 3, we have 10 possibilities, 10 possible numbers where the total will be divisible by 3. So P of 3 is going to be 10 divided by 30. And finally, we need numbers where the sum will be an even number. I mean, even in the sense, P of 2 intersection 3 is what we are trying to find. So if we talk about P of 2 intersection 3, the number should be divisible by 2 as well as by 3. Now, see the total number of numbers which are divisible by 3 are already equal to 10. Out of 10, half of them will have the total as an even number and the other half will have the total as an odd number. So half of them means 5 of them will be even numbers. I mean the total of 5 of the outcomes will be an even number. So 5 are favorable to even 2 also. So the probability that the total is divisible by 2 as well as 3, that will be out of 10, 5 of them are even. So 5 upon 30. And finally we try to compute the probability of the number being divisible by 2 or 3. So we have 2 or 3 as P of 2 plus P of 3 minus P of 2 intersection 3. So we have P of 2 that's 15 by 30 plus P of 3 that's 10 by 30 minus P of 2 intersection 3 that's 5 by 30. So this makes it 20 by 30, and finally 2 by 3 is the required probability. For all those who do not understand this formula, I have discussed the way that formula works at the end of this video, but I believe that most of you have already done this formula and you know this formula. All that you are here for are the sums. So for now I will continue with the questions, and like I said at the end of this video, I have discussed how that formula has come into the picture. The second question says that a card is drawn from a pack of 52 cards. Find the probability that the card is either a red card or a black card. So how many red cards do you have? How many black cards do you have? Number of red cards, red means diamonds and hearts included. So number of red cards are 26. If I talk about probability of getting a red card, that will be 26 by n of s, which is 52. So this will be half. Then we have probability of having a black card. A black card means it can be either a spade card or a club card. There are total 26 spade and club cards. So probability of having one of those black cards will be 26 upon n of s, which is 52, so half. Probability of R intersection B. Do we have any card which is a red as well as a black card? A card will either be a red card or it will be a black card. It can't be both at the same time. So P of R intersection B, that is the card being a red and a black card together, we don't have any such cases, and that is why the probability for this will be 0. So finally P of R union B, that will be P of R plus P of B minus P of R intersection B. So this is going to be half plus half minus 0, which is equal to 1. And if you think over it logically, see, you're taking out a card from a pack of 52 cards. The card is bound to be either a red card or a black card. What other possibilities do we have if we are taking a card from a pack of 52 cards? There's no other possibility, and that is why yes, the answer was going to be 100% possibility, indicating that the probability will be 1. Okay, so that's the answer for your first part, and with that we try to answer the second part also. The card is either a black card or a face card. So probability of getting a black card, we are answering the second question now. Probability of getting a black card, we just saw it was 26 by 52. So that's 1 by 2. Probability of getting a face card, there are a total of 3 face cards in every suit, and there are 4 suits. So the number of face cards that we have are 4 into 3, which is equal to 12. So 12 upon 52 is the probability of getting a face card, which is okay, let's do one thing. Let's keep it as 12 by 52 only for the time being, and the upper one also is 26 by 52. Now what is the probability of B intersection F? That is, you want it to be a black card as well as a face card. Now that can happen in, okay, like I said, every suit has 3 face cards. There are 2 suits which are black in color. So a face card and a black card, that together can happen if it is a face card of club or a face card of spade. And that can happen in 6 ways, because there are 3 face cards of club and 3 face cards of the spade suit. So the total number of ways in which we can have a black face card, that will be 6 by 52. And finally we go for answering their question. The card needs to be either a black or a face card. So it's B union F, and that will be given by P of B, which is 26 by 52, plus P of F, which is 12 by 52, minus P of B intersection F, which is 6 by 52. So add them up, it's 38 minus 6, which is 32, and 32 by 52. You can divide the numerator and denominator both with 4. So this gives you 8 upon 13. And yeah, that's the final answer for the B part of your second question. We go ahead with the third question. A girl is preparing for national level exam and state level entrance examinations. Sorry, national level entrance exam and state level entrance exam for professional courses. The chances of her cracking the national level exam are 0.42, means that's the probability, and the chances of cracking the state level examination is 0.54. The probability that she clears both the examinations is 0.11. Find the probability that she cracks at least one of the 2 exams. At least one means either one or 2 or both of them. And if I say that the national level exam is represented by N, then P of N is 0.42. P of the state level exam is 0.54, and P of national level intersection state level, that is the national level and also the state level examination, clearing both of them, the probability for that is 0.11. Clearing at least one of them, that means they are asking us either one or 2 or both of them, and that is represented by N union S. And as per the formula, this will be P of N, that is 0.42, plus P of S, which is 0.54, minus P of N intersection S, which is 0.11. So if you total it up, it's going to be 0.96 minus 0.11, that is 0.85. Okay, so this is P of N union S, and that's the answer for your first part. You can similarly answer the second part, that is, she cracks only one out of the 2 examinations. Think as per the Venn diagram now. If this represents the set N and this represents the set S, now only one examination means you are talking about the set here, the one which I have just marked. So the one which has been marked, that area can be obtained by n union s, and from that you are removing this middle intersection part. Okay, so to answer the second question, the answer for the second question will be, it is P of n union s minus P of n intersection s, which can be written as 0.85 minus the intersection is 0.11. So the value for this is going to be equal to 0.74, and yeah, that's how we are answering the second part. The third one is, she cracks none of the two examinations. So for the third part, none of the two examinations means the area outside N and S, because when you talk of N, she is clearing the national level examination. When you talk of S, she is clearing the state level examination. You want her to clear none of the two examinations, so you want the possibility of the part which lies outside N and S. The total probability being 1 minus, because you want the part outside N and S, let's eliminate that N union S from 1, and that will give us the answer for the third question, that is the probability for the girl to crack none of the two examinations. This will be 1 minus 0.85, which is equal to 0.15. Yeah, that's how we are answering our third question, and with that we go ahead with the next question. The fourth one says, a bag contains 75 tickets numbered from 1 to 75, and you're taking out one ticket at random. Find the probability that the number on the ticket is a perfect square or it is divisible by 4. So let's talk of it in this way. The A part will be answered in this way. The probability of number being a perfect square, from 1 to 75, how many squares do you have in total? So you have 1, then you have 4. Okay, we can say that 8 square will be 64, 9 square will be 81. So up to the squares of 8 are the numbers that we already have from 1 to 75. So there are 8 numbers which are perfect squares, and there are 75 tickets in total. So probability of having a perfect square will be 8 upon 75. Then the probability of the number being divisible by 4. So P of the number divisible by 4, or it's okay, 72 is the fourth multiple of 18. So 18 into 4 is going to be 72. So we have 18 numbers which are divisible by 4 from 1 to 75, and that is why probability of the number being divisible by 4 will be 18 upon 75. Okay, now what is probability of the number being a perfect square as well as the number being divisible by 4? So the possibilities are 4, then it is 16, then it is no 25, 36 yes, no 49, 64 yes. So 4 of the perfect squares are divisible by 4, and that is why the number being a square as well as divisible by 4, the probability for that will be 4 upon 75. And finally we answer their question, that is the probability that the number is either a perfect square or means union divisible by 4. So P of S union 4, that will be P of S, which is 8 by 75, plus P of 4, which is 18 by 75, minus P of S intersection 4, which is 4 by 75. 8 and 18 make it what? 26, minus 4 make it 22. So the final answer for that A part is 22 upon 75. Let's go ahead with the B part of the fourth question. So they want the probability for the number on the ticket to be a prime number or a number which is greater than 40. So when we talk of probability of the number being a prime number, from 1 to 10, what are the, okay, from 1 to 75 we need all the prime numbers. So 2, 3, 5, 7 are 4 prime, 2, 3, 5, 7, yeah, there are 4 prime numbers. Then we have 11, 13, 17, 19, so 4 more prime numbers. Then 23, 29 are 2 more prime numbers. 31, 37, so 2 more prime numbers. Then 41, 43, 47, 3 more prime numbers. 53, 59, plus we have 61 and 67, so 2 more prime numbers. Then 71 and 73, 2 more prime numbers. So this is making it 8, 10, 12, 15, 17 and 4. That's 21 prime numbers in total. So we have 21 prime numbers, and that is why probability of getting a prime number becomes 21 upon 75. In a similar way, probability of the number being greater than 40. Okay, so greater than 40 means we need to start counting from 41. From 41 up to 75 we have 35 numbers, and that is why probability of the number being greater than 40, that will be 35 upon 75. Probability of the number being a prime number and greater than 40. Intersection means and. So the number being a prime number as well as greater than 40 means we need the prime numbers greater than 40, which are 41, 43, 47, that's 3, plus we have 53, 59, which is 2, plus 61, 67, that's 2 more prime numbers, and 71, 73, that's 2 more prime numbers. So we have a total of 9 prime numbers greater than 40. So P intersection 40, the probability for that will be 9 by 75. And finally, the probability of the number being a prime number or greater than 40 means P of P union 40. That will be P of P, that's 21 upon 75, plus P of 40, 35 upon 75, minus the intersection, that's 9 upon 75. So we have 21 and 35, that is 56, minus 9 making it 47. So the final answer for that being 47 upon 75. And yeah, that's how we are answering the B part of our fourth question. We go ahead with the fifth question. It says the probability that a student will pass in French is 0.64 and he will pass in sociology. The probability for that is 0.45 and he will pass in both. The probability is 0.40. What is the probability that the student will pass in at least one of the two subjects? At least means either one or two or both of them. That means they are asking you P of A union B. The terminology you can give it by yourself. For now I am just using A union B. A for French and B for sociology. So if you want you can use F and S also, but I'll go ahead with P of A union B for now. So probability of passing in A is 0.64 plus probability of passing in B is, probability of passing in B is 0.45 minus the probability of passing in both of them, that is the intersection, is 0.40. So A plus B minus their intersection, and this is going to give you 0.69 as the final probability for the fifth question. So probability that the student will pass in at least one of the subjects, that's going to be 0.69. With that we take the sixth question. So for the sixth question we have two fair dice are thrown. Find the probability that the number on the uppermost face of the first die is 3 or sum of the numbers on their upper faces is 6. So let's call the first event as A. P of A, you need the probability of the number on the upper face to be a 3, and for that the probability is 1 by 6. I mean there are 6 faces, so any one of them can there are 6 faces, so 6 possibilities. You specifically want a 3 and that is why the probability is 1 by 6. The outcome of the second die does not affect that event A, and that is why probability of A remains as 1 by 6. Probability of B, the sum being 6. Now total we have 36 possibilities when we are tossing a die 2 times. Out of that the sum can be 6 in how many ways? It can be 6 as 1, 5, 5, 1. Then it can be 6 as 2, 4 and 4, 2. And finally as 3, 3. So there are 5 ways by which we can have the sum of the numbers as 6, and the probability of B is going to be 5 by 36. What about P of A intersection B? A intersection B means you want the first number specifically to be 3 and the sum also to be equal to 6. That can happen only in one way, that is 3, 3. And that is why the number of possible outcomes are just 1. So the probability becomes 1 by 36. And finally, to answer their question, they are asking us the probability of A or B. So P of A or B means P of A union B. That will be P of A, which is 1 by 6, plus P of B, that's 5 by 36, minus 1 by 36. So if we try to evaluate the numbers, we have 6 minus 1, which is 5. This will be 6 plus 5, making it 11, minus 1, making it 10. So 10 by 36, because we need to write this number as 6 by 36, okay? Yeah, so we have 10 by 36, which is 5 by 18 as the final probability for the sixth question. Okay, with that we go ahead with the seventh one. They have already given us P of A, P of B and P of A union B. They are asking us to calculate P of A intersection B. We can easily do that with our formula. P of A union B is going to be P of A plus P of B minus P of A intersection B. Okay, so 1 by 2 you can write that as 4 by 8. 3 by 8 plus 4 by 8 makes it 7 upon 8. You can take this P of A intersection B on the left and 5 by 8 on the right. So that will give you P of A intersection B as 7 by 8 minus 5 upon 8, which is 2 upon 8, and that will be 1 upon 4. So the answer for that first part is going to be equal to 1 upon 4. Try to answer the second question. They need P of A complement intersection B complement. So there's a rule which says that the way you split the complement is, if you have P of A union B, the whole complement, you can split that complement and attach it with each of the two terms. But when you expand a bracket with the complement in this manner, union becomes intersection, intersection becomes union. So this becomes intersection, and yeah, P of A complement intersection B complement will be the value for P of A union B complement. You can imagine it as per the Venn diagram also, and if you imagine it in terms of areas, you will realize that this area and this area are ultimately going to represent one and the same thing. Also P of A intersection B complement, that will be P of A complement, because I said when you are splitting the complement, the middle term changes, intersection will become union. And finally, with this, what you can do is, you can pull out that complement common, and just like you're doing it over here, when you expand with a complement, you change the sign in the middle. Similarly, when you take out a complement common, you just change that middle sign. So you have A, it will become union B and the whole complement. So P of A union B, the whole complement, this is going to be 1 minus P of A union B, which is 1 minus A union B is 5 upon 8. So the right answer for that will be 3 upon 8. I mean, that's the answer for the B part. And then we go ahead with the C part. P of A complement union B complement, pull out that complement common, and this becomes P of A intersection B, the whole complement. This is 1 minus P of A intersection B. This will be 1 minus A intersection B, we just got it as 1 by 4. So this will be 1 minus 1 by 4, which is equal to 3 by 4. And yeah, that's how we are answering the C part of our 7th question. With that, let's go ahead with the 8th question, which is a similar one. So we have two events A and B, for which P of A union B is given, P of A intersection B is given. P of B complement is 1 upon 3, which tells you that P of B is going to be 1 minus P of B complement, which is 2 by 3. Find P of A. So apply the formula P of A union B, which is 5 by 6. That will be P of A plus P of B, which is 2 by 3, minus P of A intersection B, which is 1 by 3. This becomes 1 by 3, and that 1 by 3 goes on the left. So you get 5 by 6 minus 1 by 3. You can write 1 by 3 as 2 by 6. And finally, this P of A becomes equal to 3 by 6, which is equal to 1 by 2. And yeah, that's how we are answering the 8th question. With that, we go ahead with our 9th question, and we have a bag contains 5 red and 4 blue balls and an unknown number of m green balls. If the probability of getting both the balls as green balls when two balls are selected at random is 1 by 7, find the value of m. So in the bag, we have a total of 5, 4 and m balls, out of which we are selecting 2 balls. So the sample space will contain 5 plus 4, which is 9, plus m, C2 possibilities, because we are selecting 2 out of these many balls. The number of selections are 9 plus m C2, and number of ways by which we can select a green ball, that's going to be MC2 ways, because 2 balls out of m green balls can be selected in MC2 ways, and the probability has been given to us as 1 upon 7. So we can say that 1 upon 7 is going to be MC2 divided by 9 plus MC2. Now we can write MC2 in the numerator as m into m minus 1 upon 2 into 1. I am not writing that 2 into 1 because that 2 into 1 will get cancelled with the 2 into 1 in the denominator of this term. So in the denominator we will have 9 plus m into 8 plus m, and there was a 2 into 1 in the denominator of this, which cancels off 2 into 1 in the denominator of this. So let's just eliminate this part, and we know that this value is 1 upon 7. Take that 9 plus m into 8 plus m on the left hand side. So when you expand it, you have m square plus 17m plus 72 equal to 7m square minus 7m. Take everything on the right hand side. So we have 6m square minus 7m minus 17m, that's minus 24m minus 72 equal to 0. You can cancel throughout by 6, so you have a 4 here, and this will become 12. Factorize it, you get m minus 6 into m plus 2 equal to 0. So the only possible value for m is going to be 6. You cannot have m as minus 2 because m strictly has to be a positive integer, because m was the number of green balls. It doesn't make sense when you say m is minus 2. So the value of m out there will be 6, and yeah, once we get the value of m as 6, we have answered our 9th question as well. We go ahead with our last 2 questions. The 10th question says, from a group of 4 men, 4 women and 3 children, 4 people are selected at random. So it's very clear that the total number of possibilities in the sample space are total number of people 8 and 3 11. Out of 11 you are selecting 4 people. That can be done in 11C 4 ways. Find the probability that no child is selected. If no child is selected, then the selections have been made from 8 men and 8 women. And in that case, to answer the first question, the probability will be 4 people out of 8 can be selected in 8C 4 ways, and n of s being 11C4, so that's your probability. 8C4 will be 8 into 7 into 6 into 5. Upon there will be 4, 3, 2, 1, but that 4, 3, 2, 1 will get cancelled with the denominator of this term. So in the denominator now we will be having 11, 10, 9 and 8. So we have 8 getting cancelled. Then we have 3 2s are, 3 3s are. Then we have 2 into 5 giving you a 10. And yeah, the final answer there becomes 7 upon 33 for the first part. We go ahead with the probability for the second part. Exactly 2 men have to be selected. So if you are selecting exactly 2 men, then 2 out of 4 men can be selected in 4C 2 ways. But the remaining 2 people can be selected from the 4 women and the 3 children. So there are 7 people out of which we need to make the other 2 selections. That can be done in 7C 2 ways. It's men and the other people, and that is why we are multiplying the 2 possibilities. So that's the number of possible ways for the second part. And in the denominator you have n of s, which is 11C4. So let's try to evaluate this one. We have the required probability as 4C2, that's going to be 4 into 3 upon 2 into 1, that's 3 into 2, which is equal to 6, into 7C2, which is 7 into 6 upon 2 into 1, that is 7 into 3. In the denominator we have 11C4, so that's 11, 10, 9, 8, and a 4, 3, 2, 1 goes to the numerator. 4, 3, 2, 1. Okay, so 4 into 2 is going to give you 8. 3 into 3 gives you 9, and finally 6 into 7 upon 10, right? So 2 3s are, 2 5s are, and the final probability that we are left with is 7 upon 55. Yeah, that's the probability for the second part of the 10th question. Going ahead with the 11th question, we have a number is drawn at random from the numbers 1 to 50. Find the probability that it is divisible either by 2 or by 3 or by 10. Okay, so this time we have a total of 3 possibilities. Probability of the number being divisible by 2. So from 1 to 50 we have 25 odd and 25 even numbers. So this will be 25 upon 50. I know we can write it as 1 by 2, but let's not do it now. Then we have probability of the number being divisible by 3. 16 into 3 is 48. So we have 16 numbers divisible by 3. The probability of the number divisible by 3 is going to be 16 upon 50. And the probability of the number being divisible by 10, that's going to be 10, 20, 30, 40, 50. So that's just 5 numbers out of 50. Then try to find out the number of numbers which are divisible by both 2 and 3. So P of 2 intersection 3. That is, see, if a number is divisible by 2 as well as 3, then the number is divisible by 6 also. And we have 8 such numbers because 8 into 6 will be 48. So we have 8 divided by 50 as the probability of the number being divisible by 2 and 3. Probability of the number being divisible by 3 and 10. That will simply be equal to 30. So there's just one number like that, and that is why the probability is 1 by 50. Probability of the number being divisible by 2 and 10. So we have 2 such numbers, 20 and 40. So this will be 2 by 50. And probability of the number being divisible by 2 and 3 and 10. So 2 and 3 and 10. So one such number is 30, and yeah, that's the only number out of 10, 20, 30, 40, 50 which is divisible by all three of them. So this will be 1 upon 50. Finally, if we have to find the possibility of P of A or B or C, that is P of A union B union C, this will be P of A plus P of B plus P of C minus P of intersections of two of them. So A intersection B minus P of A intersection C minus P of B intersection C, and plus we will add the intersection of A intersection B intersection C. So this will be P of A plus P of B plus P of C, that's 25 and 16 and 5, that's making it 46, minus these three terms. So 46 minus 8, 38, minus 1, which is 37, minus 2, which is 35, plus this, so plus 1, that's making it 36 upon 50, and yeah, that's the final probability of the number being divisible either by 2 or by 3 or by 10. So this is going to make it 18 upon 25, and yeah, that's the final answer for the 11th question. For all those who are willing to know how this formula has come into the picture, here's the explanation. Say for example, I'm making a Venn diagram with one of the sets being A and the other set being B. N of A represents the number of elements which are there in the set A, or I can say that N of A represents this entire region, the circle that I have drawn for the set A, that is represented by the term N of A. Similarly, N of B will represent the entire set B, which is the circle that I have drawn for B. Now, if you realize there's a region common to both A and B, the region common to both A and B, we can say that it represents the intersection of A and B, and we say that N of A intersection B, this will represent the number of elements that are there in the intersection of A and B. We can say that these are the elements which are common to both A and B, that is, these are elements which are there in A as well as they are there in B. Now what about N of A union B? When we say A union B, we are referring to this entire region that we have here. A union B means the elements which are there either in A or in B, or they are there in both of them. So N of A union B means you combine A and B together, and whatever is the total you get is represented by A union B. You can say that the elements that we have in the set A union B are basically there either in A, or they are there in B, or they are there in both A and B. So N of A union B can be written as N of A plus N of B. But now when you say N of A plus N of B, see, what you have done is you included the elements of A, you included the elements of B, but the common elements, you counted them twice. You had to count them only one time. So because you have counted them twice, you will subtract them one time, and you get that last term minus N of A intersection B, and that is what forms your formula. Now we divide both the sides with N of S, so that introduces N of S in the denominator of every term. N of S means the total number of elements in the sample space, and N of A union B upon N of S, that makes it P of A union B. And exactly with the same explanation, every other term which was N of A or N of B or N of A intersection B becomes P of A, P of B and P of A intersection B, and that's how you get your formula. There's one more formula. This formula is related to a total of 3 sets, and it works exactly in the same way like the 2-set formula. So if we are having a total of 3 sets which are A, B and C, what we say is P of A union B union C. Now P of A union B union C means we are including this entire region, that is the elements which are there either in A, or they are there in B, or they are there in C, or they are present in A and C, or they are present in A and B, or they are present in B and C, or they are present in all 3 A, B and C. In short, the entire region covered by the 3 circles that I have drawn here is represented by A union B union C. The probability of A union B union C will be, okay, now see the logic that we are applying is for the number of elements, but ultimately when you divide both the sides with N of S, each N term gets converted to the probability P term. So I am directly writing a P here, but yeah, the imagination that we will go ahead with is the number of elements. So this will be equal to P of A plus P of B plus P of C. When you do this, there are certain elements that you have counted 2 times. The elements that were common to A and B are counted 2 times when you say P of A and P of B. So we need to eliminate from this P of A intersection B, that is the elements common to A and B. We counted them twice, so we are eliminating them once. We will eliminate them once because at least one time we need to count them. Similarly, we are eliminating P of B intersection C and P of C intersection A. Now think over it. When you said P of A plus B plus C, you counted the elements of A intersection B intersection C. A intersection B intersection C means this area. You counted the elements common to the three sets one time, two time, three times. But when you subtracted these terms, when you subtracted A intersection B, B intersection C and C intersection A, you subtracted A intersection B intersection C, these elements three times. You are adding those three elements, those elements three times. You are subtracting them three times, which means till now you have not calculated these A intersection B intersection C elements. If you have still not counted them, then you need to count them by adding a P of A intersection B intersection C. Okay, that's how the formula works for a total of three sets. You can extend the analogy to a total of four sets. For four sets, you will have 1 plus 2 plus 3 plus 4. Then minus you will have 1 intersection 2, 2 intersection 3, and the combinations of 2, 2 that you can form, you need to subtract all the possible 2, 2 combinations. Then you will add all the possible 3, 3 combinations, and then you will finally subtract a combination of 4. That works for 5, 6, 7, 8, 9, 10 sets. But the more number of sets that you include, the more complicated the formula will become. We don't have to deal with these bulky formulae in our 11th and 12th standard. But yeah, knowing the formula for three sets is essential. And here's where I've discussed the formula with you. Just as a matter of general information, I have also told you an extra point that it is applicable for more than three sets also if they are present. And yeah, that's it with the conceptual part of this. I am done with whatever I wanted to discuss in this video. I hope that the contents have been someplace somewhere helpful to you in your preparations. Thank you for watching.